So hey, welcome to the fifth in this Rocketry Series, episode 5, and we're going to talk about the scratch build of the VR2 rocket that we've been designing in the previous episodes and making parts for. As you can see, I've built it and flown it. That was the footage of its first flight up at International Rocketry Week, and it flew really well. We built most of it there, so most of this video is going to be in photographs. This first photograph is drawing a circle and then marking 3 equidistant lines at 120 degrees, which means that we can mark some marks on the bulkhead that we cut for the upper payload section that we're going to use to help us mark the tube as to where the fins go. So I then placed this bulkhead in the back end of the tube that we're using for the booster section, where we wanted to put the fins, and I transferred the marks onto the tube off the bulkhead that I'd placed loosely in the end of the tube. And then there's this cool thing you can use, just any piece of sort of angled metal, or some people use a door frame. I've got some various different sizes of aluminium extrusion that are set at a 90-degree angle. Brilliant thing about those is if you place them on a tube and draw a line using them as a ruler, they'll always be kind of perpendicular to the center of the line, so they'll always create a vertical line or a straight line for you to attach your fins to. We used the snazzy fin jig that I built a while back, which to be honest is a bit complicated, but is going to be the subject of another video. It's basically a tool that allows you to put on fins and guarantee that they're vertical and straight, which is what we want. But it's true to say that you can do this by hand. So we simply what you could do is just add some glue, some PVA to the bottom of the fin, place it over the line that you've drawn, center it up on the line and make sure it's vertical. Good tip is stick a tiny dab of super glue at either end of the fin, and that sets quickly so that you can get it straight, and then it kind of lets the PVA glue go off. So here you can see that the fins are on, and I've started adding some extra glue to form some fillets down the side of the fins, which is what we do to strengthen them. We can see here the motor mount tube with the centering rings on. So the motor mount tube is an Estes 24mm tube. The centering rings are ones that we cut on the CNC. And I've drilled a hole in the tube, in the centering ring that's going to be the top one, because instead of doing the Estes thing of adding elastic and sticking it to the inside of the body tube, we're going to use some of this Kevlar thread that I got from an eBay shop that sells kite supplies. Brilliant thing about Kevlar is, yes, it's not stretchy, but it's fireproof, so it will last a long time and it won't kind of degrade. What we did was I drilled a hole through this top centering ring, placed the Kevlar through, tied a knot behind it and glued that knot with super glue up to the back of the hole so it can't kind of move. But I left about 10 centimeters. You can just see a curl of Kevlar underneath the centering ring, and I left about 10 centimeters, enough to go round the body, the motor mount tube twice. So I wrapped that round and then I stuck it on with lots of PVA glue, just so that it's got that couple of turns stuck to the tube as well as the knot, makes everything kind of nice and strong and not going to go anywhere. It's important when you're using something that's not stretchy to use at least a couple of times the length of the entire rocket of the cordage as your kind of recovery bridle, the thing that ties the bottom half of the rocket to the top half of the rocket and where you attach the parachute. I'd probably go for 3, 3.5, maybe even 4, because the longer it is, the more chance that the energy of the thing exploding apart is dissipated and it doesn't cause a rip. The other thing on the centering rings is the bottom centering ring isn't glued on here, but it needs to be placed high enough for this little grey thing you can see in the lower left hand corner, which is the inside of the motor retainer, the Estes 24mm motor retainer that we're going to use on this build. So it needs to be glued on as high up the motor mount tube so that when you put that bottom bit on, it's flush. Other thing in this picture to note is the coupler tube that we 3D printed. We've drilled a couple of holes in that bulkhead and super glued it to the top of the coupler tube. So here we see now I've inserted some glue inside the rocket body and I've pushed in the dried assembly of the motor mount tube with the 2 centering rings on. I've started again, I'm still building up fillets. I probably added like 4 or 5 layers of glue along the inside of the fin edges to ensure that they are on really strongly. You can see there that if I screw the motor mount motor retainer cap on, it'll go flush up to the body. Next thing we needed to do is we need some launch lugs. These are basically things that keep it stable on the rocket, keep the rocket stable rather on the launch rail until it comes up to speed. We simply drew a longer line and then use two 2 centimetre sections of paper tubes stuck on the line. This is obviously after we've built it. I forgot to take a picture of this, but we super glued in the coupler tube with the bulkhead inside it at the top end and into the upper section we're using as the payload bay. We glued it in. We used super glue and we only put it in a couple of centimeters. The idea is that the lower part of the coupler that goes into the bottom section, you want to have at least one diameter of the body tube length of coupler. So that was just a little bit over. And then of course the motor mount is interesting because the motor has nothing to stop it from going straight through, like the ones that we showed in an earlier video, the Estes things where we have a hook system and a block in the tube. There's no block in this tube. So what we do is we create a thrust ring by adding a thin, what I've done here is I've added a good few turns, maybe 5 or 6 turns of a thin strip of masking tape, maybe 2.5, 3 millimeters wide. I've wrapped it around the bottom of the motor neatly and evenly, and then I've added some super glue to reinforce that. I'll obviously let it dry completely before you try putting it in the tube, or else you'll glue a motor into your tube permanently. And of course these need to be pulled out and replaced with the next one for your next flight. So yes, let the glue go off, and it forms a really solid, hard, tough ring that's as hard as the motor tube itself. So yeah, when you slide it in and then tighten the retaining nut over the top, it all stays in place and the thrust can be pushed through the rocket. So let's have a quick look again at the launch. It flew really well. Hope you enjoyed this bit of the series, and I'll see you next time. Thanks for watching.